All right, good morning, guys. Today we're going to be covering 7.10, area and solving a triangle on the coordinate plane. Our learning target will be I can use right triangle trig in the distance formula to solve for the area of any triangle. So let's go ahead and get started by deriving the area formula for any triangle using trigonometry. So we're going to write a trigonometric ratio in terms of angle C. The height h of triangle ABC will be one of the sides that we use in our ratio, as well as any of the other sides. So I'm going to go ahead and use side length B, because of course A is the entire length down here. So therefore it makes sense for me to use side length B. So therefore when I set up my trig ratio, since I have opposite h and hypotenuse B, I'm going to use sine. So I'm going to have sine of segment sine of angle C is equal to segment AD over segment AC. Now, of course, if I replace those with the variables that we have, that'd be H over B. So therefore, sine of angle C is equal to H over B. And what I'm going to do from here is I'm just going to go ahead and solve for the variable H. To do that, I multiply both sides by B, and that will give me H is equal to B sine of angle C. Now, again, we're dealing with area here. And we know that the area of a triangle is areas equal to 1/2 base times height. So in this case, I have height. I have h now. H is equal to B sine of angle C. So I can plug that in for h. And then if I look at this triangle, the base of it, the bottom of it, is segment A. So therefore, our area is equal to 1/2 A times B sine of angle C. And again, we got that through using substitution. So all I did was I substituted in B sine of angle C for the variable h. Now, this is our area formula, and it will work for any triangle that you run into. The clear indicator that you can find the area of the triangle is if you run into side, angle, side within a triangle. If you have side, angle, side of a triangle, then you can use this area formula. So again, those are the steps in order to derive the area formula. And again, some things that we need to make sure of is that this can be used only when we have side, angle, side. So when we have two sides of a triangle and the included angle. Now again, the included angle just means the angle that's sandwiched in between here. And again, that area formula is 1/2 AB times sine of angle C. Now again, make sure that you have this in your notes because that area formula will be extremely useful for you guys. It's a pretty easy formula to memorize as well, because if I look at this, I just have my ABCs. A times B, sine of C. Now, let's go ahead and practice out this formula sum. So here's our first example. Find the area of the triangle to the nearest tenth. So first off, if we look at this triangle, the first thing that we should do is identify what is given to us. And on this triangle, we have a side, an included angle, followed by another side. So if we have side, angle, side, that means that we can use our area formula. So we have area is equal to 1/2 A times B sine of angle C. Plugging in our values, we'll have area is equal to 1/2 3.2 times 4.7 sine of 142 degrees. We can enter in this entire thing on our calculator. When we do, that will give us the area. So the area of this triangle would be 4.63 meters squared. And of course, we want to round to the nearest tenth, so I'm going to go ahead and rewrite this as 4.6 meters squared. Now, a couple of things on this one. Your answer will always be units to the second power because we're dealing with area. Anytime that you're dealing with area, you're in 2 dimensions now. And if you're in 2 dimensions, then you need it to the second power. Further, when you're plugging in for A and B, it does not matter which one you give 3.2 and 4.7. You can switch these numbers around. It doesn't matter. So keep that in mind as well. And lastly, this variable inside the sine function, again, that's always going to be an angle measure. So therefore, that angle will always go inside for your variable C. All right, let's try out our next one. Next up, we have this triangle. Again, we're going to try and round it to the nearest tenth with the area. So again, we look at the triangle and we notice that we have side, angle, side. So therefore, we can use our area formula. So again, we have a side length of 4.1 and 3.2, and then the angle in between is 62 degrees. Plugging it into our area formula, area is equal to 1/2. I need to make sure that I draw in that 1/2 here. Area is equal to 1/2 A times B, the sine of angle C. From here, we plug in our values, which will give us 1/2 times 3.2 times 4.1 sine of 62 degrees. This is what you can enter into your calculator. Again, you can substitute 0.5 in for 1/2. I encourage you guys to do that on your calculators when you're entering it in. Entering this into your calculator will give you your final answer of area being about 5.8 centimeters squared. All right, so those are the easier types of problems. And just in case you run into a problem where you don't have side angle side, what you can do is you can use law of sines or law of cosines to figure out your missing sides and angles. Now again, law of sines is 7.7 video. Law of cosines is the 7.8 video. So if you guys need a refresher on those, please feel free to watch those videos to help out. So again, if you don't have your missing side or missing angle and you need those, always feel free to use those laws. Next up, we're going to ramp up the difficulty a little bit, and this time we're going to work on the coordinate plane. So we're going to find the area of triangle JKL, and we're given just the 3 coordinates of those points. So the first thing that we do is we draw up the coordinates and we go ahead and play connect the dots to make our triangle. Now, since we have a triangle here, we're going to first determine what's going on with the angles. So I want to determine if this is a right triangle or not. And the way that I can do that is through slope. So if I want to determine if this is a right triangle, we use slope. Now again, the formula for slope is y2 minus y1 over x2 minus x1. That is our equation for slope. So using this equation, I plug in our points for slope. Now looking at all 3 angles, the only angle that seems like it could be 90 degrees is angle J. So let's go ahead and check out angle J. So to do that, I'm first going to find segment JK. I'm going to see the slope of segment JK. So the slope of segment JK, that would give us 5 minus 2 over 3 minus negative 3. Of course, 5 minus 2 is 3. 3 minus negative 3 is positive 6. Double negatives turn to a plus. 3 over 6 is the same as 1/2. So the slope of KJ is 1/2. Let's go ahead and find the slope of JL. Because if these slopes are perpendicular, meaning their slopes are opposite and reciprocal, then that means that they are perpendicular and intersect at 90 degrees. So finding the slope of JL next, we're going to have 5 minus 1 over 3 minus 5. 5 minus 1 is 4. 3 minus 5 is negative 2. Negative 2 will go into 4, negative 2 times. Now, looking at these slopes, they are opposites. One's positive, one's negative, and they're reciprocals. If I flip the fraction 1/2 over, I get 2. So therefore, these are opposite reciprocal slopes. Therefore, they are perpendicular to each other. And since they're perpendicular, angle J is 90 degrees. Next, now that we've certified that this is a right triangle, we're going to go ahead and find out everything in this triangle. Now, I know that we are looking to find the area, and I'll show you guys a little bit of shortcut on the next slide for this. But as of right now, I just want to show you guys how we can find everything on this triangle. So, next up, I'm going to find the distances of each side length. And to do that, we're going to use the distance formula. Now, the distance formula is extremely important that you guys memorize this formula. It will be used quite often. And again, it's going to be used on standardized testing, college entrance exams, a bunch of different places. So make sure that you memorize the distance formula. That formula is the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So using the distance formula, we'll go ahead and find the distance of kj first. So for kj, we're going to have 3 minus negative 3 squared plus 5 minus 2 squared. 3 minus negative 3 will give us 6 squared. 5 minus 2 will give us 3 squared. 6 squared is 36. 3 squared is 9. 36 plus 9 is radical 45. So therefore, kj's distance is radical 45. Next up, we're going to go ahead and find out JL next. So using the distance formula for JL, we're going to have 3 minus 5 squared plus 5 minus 1 squared. 3 minus 5 is negative 2. 3 minus 5 is negative 2 squared. 5 minus 1 is 4. So we have negative 2 squared plus 4 squared. Negative 2 to the second power will give us 4. 4 squared is 16. 4 plus 16 will give us 20. So therefore, the distance of JL is radical 20. Next, we're going to find the distance of KL. And I don't need to use the distance formula for this next section because it's a right triangle and I have two sides. So therefore, I can use Pythagorean's theorem. KL squared equals KJ squared plus JL squared. Plugging in our values for KJ and JL will give us KL squared equals radical 45 squared plus radical 20 squared. The squared and the square roots cancel, leaving us with KL squared equals 45 plus 20, which is, of course, 65. If I want to get rid of the square, I take the square root of both sides, giving us KL is equal to radical 65. Now that I have all of my side lengths, I'm going to go ahead and find out some angles. I'm going to find out angle K and angle L. Starting with angle K, the only way that we can solve for angles within a right triangle is either the law of sines or cosines, but also, since it's a right triangle, we can use inverse trig, and that's exactly what we're going to do. So I'm going to go ahead and start with angle K. I label my sides of the triangle based upon angle K. So the side opposite is JL, radical 20. The hypotenuse is radical 65, and the adjacent is radical 45. What I'm going to use is I'm going to use tangent. I could have used any trig function that I wanted here, but using tangent would just work. Again, I just chose to use that one. Don't need to use it. So plugging in my values for tangent, I'll have tangent of angle K is equal to radical 20, opposite, over adjacent, radical 45. To get to get angle K by itself, I need to get rid of tangent. The only way that I can get rid of tangent, we just talked about it, is through inverse trig. So I take the inverse tangent of both sides, also known as arctangent. So I take the arctangent of both sides. Tangent and arctangent will cancel, leaving me with just angle K. On the other side, I'll have arctangent, because what I do to one side I must do to the other. Arctangent of the ratio of radical 20 over radical 45. From here, I can enter this into my calculator. Plugging this in will give us angle K is equal to 33.7 degrees. Now that we have angle K, we can find our final angle, angle L. To do that, I'm going to use the triangle angle sum theorem. Angle K plus angle J plus angle L equals 180 degrees. I already know angle J and angle K, so I can say angle L is equal to 180 degrees minus 90 minus 33.7. That'll give us the final answer for angle L as 56.3 degrees. Lastly, we're going to go ahead and find the area. and I'm going to use angle L to find the area. On the next slide, I'm going to show you guys a shortcut for this type of problem. But for angle L, I'm first going to go ahead and find out the sides that are next to it, the sides that are surrounding angle L. And that would be radical 65 and radical 20. They are surrounding this included angle. So therefore, area is equal to 1/2 A times B sine of angle L. Plugging in our known values, we'll have area is equal to 1/2 radical 20 times radical 65 sine of 56.3 degrees. This is what we want to enter into our calculator. Doing so will give us the area is about 15 units squared. So again, this is a way to find everything within a triangle. Now I'm going to show you guys a shorter way to solve this problem. And again, it's going to be the exact same problem. Feel free to pause the video and copy all this down into your notes if you need to, and then we'll continue on. All right, next up. Again, I'm just going to show you guys a shortcut here. So if you notice, the first couple of steps are the exact same thing as what we did on the last problem. We have the same coordinates, we have the same triangle, we have the same everything. So again, we always start off by finding out if this is a right triangle or not, and we can do that using slope. If it's not a right triangle, we can just continue on using the distance formula, and that's completely fine as well. So, using the distance formula, I find out each side length, kj, jl, and once I find kj, I get radical 45. I plug in back for jl. I find out that jl is radical 20, just like on the last problem. So everything up to here is the same. So we now have our two sides. Now, look at our triangle. What's on our triangle? Well, we have side, angle, side on our triangle. And if we have side, angle, side, that means that we can find the area. So I can use the area formula at this point. The area formula, of course, is area is equal to 1/2 A times B sine of angle C. So for us, we're going to go ahead and have area is equal to 1/2 A times B sine of angle J, the angle included in between. Well, this will give us area is equal to 1/2 radical 45 times radical 20 sine of 90 degrees. If you think back to the unit circle, where could I find sine of 90 degrees? Well, 90 degrees was at the very top of the circle. And if you recall, that point was 0, 1. Within the unit circle, the sine value is always the y value. So when we were at 90 degrees, we were at the point 0, 1, which means that the sine of 90 degrees is 1. So therefore, this is equal to 1 right here in red, which means that this is just my base and this is just my height, which makes sense because it's a right triangle. When you guys were finding out the area of triangles in the past, you would have always had to have a right angle, and then you would have just had some basic numbers, 3 and 4. You would have been like area is equal to 1/2 3 times 4. And that's essentially what's happening here. We have our right angle, we have our base and our height, so we're just multiplying it out. And again, that's because the sine of 90 is just 1. If it was a different angle, then of course that would change slightly, as we saw on the last example when we were going through this problem and using angle L instead. So plugging this all into our calculator, in fact, gives us the exact same answer of 15 units squared. All right, thank you guys so much for watching today. I appreciate you guys taking the time to watch this video. If you guys have any questions or need anything, please let me know. Have a great